So, welcome to this class on oligosynaptic and polysynaptic reflexes. So, this is part 2, I hope of 2 parts. In the previous class we discussed the case of oligosynaptic reflexes 1A and 1B and polysynaptic reflexes of tonic stretch reflex and flexor reflex. In this class we will start our discussion with tonic stretch reflex and we will discuss other cases, peculiar cases such as tonic vibration reflex, and we will discuss about interactions between these pathways and how interjoint and interlimb reflexes happen, because this is more complicated than say what we have studied so far. What we have studied so far is monosynaptic and disynaptic. If a muscle is slowly stretched, okay, so let us remember what do I mean by that. A muscle is stretched, but the rate at which it is stretched is relatively low, right. At first the resistance to this stretching is happening due to passive properties. So, that is that response. Let us remember that the muscle is made of contractile materials. So, if I pull the material is going to respond. So, there is response due to the material properties, passive material properties, or due to what we call as passive elasticity. Then at some point, at some threshold, there is going to be a response in terms of recruitment of alpha motor neurons which actively resist. Now, let us remind ourselves of the difference between passive resistance and active resistance. Passive resistance is coming from the muscle alone. This will happen even if the muscle is not innervated by a neuron. So, if the muscle is not innervated by a neuron and let us say that it is isolated, even in that case when I am stretching there is going to be a resistance to that stretch that is offered by the material. Okay. So, this is what we call as passive elasticity, but when the muscle is innervated by a neuron and it is stretched, then the neuronal connectivity ensures that there is active. So, when we say active, there is going to be an influence of alpha motor neurons. So, these alpha motor neurons get recruited and they contract, it is like the muscle is getting stretched and it is trying to resist that stretch actively through alpha motor neuronal activation. So, that means this alpha motor neuronal activation must happen where? So, these alpha motor neurons are located in the spinal cord. So, they must be excited through some means, somehow they get leading to what is called as an active force development. This is and this increases, the characteristic is that excuse me, that is the characteristic. This is called as we said as tonic stretch reflex. The whole curve is called as the tonic stretch reflex characteristic. Let us remind ourselves of what is the phasic part. Phasic stretch reflex is the T reflex or the monosynaptic reflex. As soon as I stretch, immediately there is a response or the transient response. This response is the steady state response, is it not? This is what we said in the previous class. This is the so called steady state response. Now, this gives us an impression that on the x axis is length and on the y axis is force. So, that means I could come up with a measure similar to stiffness. I could find the slope, the force developed in the spring is proportional to the displacement, where F is the force and x is the displacement, k is the spring constant. To find k, I could do that by finding the slope of the force displacement curve. This is what we would do, mechanical engineers would do, right not. Now, I could find a similar thing in that case and I could come up with a notion of stiffness for this. For a long time it was thought that muscles are like springs, muscles behave like springs. This is only approximately true. Muscles are viscoelastic, but it is not just that, there are more complications. What is not shown in this picture is these. Let me show what else is there. So, I am going to erase this, I am going to talk about other things. if the threshold is here for example, and the threshold can be at multiple lengths, can be modified, it could go like that or it could go like that. Now realize that this slope is different from this slope, or let us say if the threshold is here, it could go like that, this slope. All these things give rise to different k's, k1, k2, k3, but not just that. If you consider this to be an x naught at the initial resting length of the spring, there are going to be multiple x naughts. I am going to call this as x naught 1, x naught 2, x naught 3, etc. It seems like this muscle is a spring with multiple resting lengths and with multiple stiffnesses, or in other words it is not exactly a spring. A real spring that we or at least in the engineering parlance, in spring as an engineering system has a resting length and has a stiffness. Okay. So, here we have a system where a system that behaves like a spring, yet its stiffnesses seem to vary at multiple levels, and not just that, it seems like there are multiple resting lengths. So, this tonic stretch reflex and this threshold itself can be controlled. So, in other words, at what point the force will begin to develop is something that can be controlled by the central nervous system. Now, that, and it is, there is a whole theory that talks about how this parameter, that is the threshold of the tonic stretch reflex alone can serve as a control parameter for movements. Okay. We will talk about that in future classes. Okay. For now it is sufficient for us to know that there can be multiple thresholds and there can be multiple slopes. So, it is way more complicated than what we have seen in the previous cases of monosynaptic disynaptic reflexes. So, that is one. So, this is tonic stretch reflex. The other case is the case of tonic vibration reflex. Now, in this case, suppose I am performing a vibration, okay, and I remove it here. So, this vibration causes a change in the force level that is produced by the muscle. Now, this is why does this happen? By the way, let us look at these terms: tonic vibrations. So, tonic in some sense refers to, we said tonic refers to steady state levels, whereas vibration by definition involves high frequency change of something. These incompatible terms somehow become compatible in the case of the muscle reflex that is produced. If a vibration is applied, it turns out that the muscles contract and produce a force, that is the force that is produced. By the way, an important difference between other reflexes and this reflex is that it is possible for me to suppress this, reduce the amplitude of this reflex, or even completely remove this by pure thinking. We defined early on, long time ago in one of the previous classes, that a reflex is something whose amplitude I cannot control by pure thinking. This is what we defined, and I told that is a working definition that works for that particular context for now, and I told that there will be cases in which it will fail, and here is an example of where that definition has failed. I could refuse to respond to vibration, then there will be no response. An individual can make that choice. So, it can be suppressed, or its amplitude can be reduced, or completely attenuated, completely removed by pure thinking. What does this mean? This means that there is a great amount of supraspinal influence on this reflex. Supraspinal means something that is coming from the head. Okay. There is an amount of supraspinal influence that could change the way this happens. Now, what could be the source of this? Well, afferents, mainly 1A afferent and other afferents, and so it is believed that the difference is the behavior, the change in the behavior of monosynaptic reflex that is caused due to vibration. So, what happens is that if there is vibration, the monosynaptic reflex amplitude changes. So, here it is something, here it is different. That difference is due to vibration itself, but how is that, what is the mechanism? When people investigated it, is widely believed that this is of presynaptic origin. So, that means H reflex amplitude or the monosynaptic reflex amplitude can be modified by vibrations. Okay. There is more actually. What other things that could happen? Illusions. If the person's eyes are closed and you vibrate, right, it gives people illusions of positions or limb positions that can not be achieved by anatomical means. For example, hyperextension of the elbow is felt when you vibrate these muscles, when you vibrate the muscles of the upper arm, and so on and so forth. Okay. Several things exist. So, but we will discuss this here and we will briefly stop here. So, this is the case of tonic vibration reflex. Then I discussed earlier that inputs from 1A interneurons, 1B interneurons are received, they basically send information to multiple interneurons. These are spinal interneurons, this can be any number. All this information converges onto these interneurons or to alpha motor neurons. So, as I said earlier in the previous class, examination of the spinal cord gives you the impression that it is a complete mess, the connections are all completely messy and you cannot make sense out of this. That means that our classical neurophysiological approach is not in a position to explain these things. So, that is because there are just so many neurons and it is not clear which is connecting to which, what are the connections between these, etc., etc. So, that is not known. So, that is at the level of spinal cord. If that is at the level of spinal cord, one has to imagine what will happen at the level of brain. Okay. This is at the level of spinal cord, right. So, there is a great amount of interaction among reflex pathways. It is sufficient to say that there is at least convergence and divergence in the reflex pathways, both at say for example, the 1A neurons, 1B neurons and alpha motor neuronal pools. So, this is going to be a recurring theme in this course. There is convergence, that means a neuron or a set of neurons receive inputs from multiple sources. So, let us remember 1A afferents and 1B afferents are different sources, other afferents is a different source. So, a neuron or a set of neurons can receive inputs from multiple sources. So, information converges there, and also information or commands can diverge, they can go to two different muscles. Sometimes they can go to two muscles on two sides of the body, which is very weird, because the control pathways are very different. So, it can cross over to the other side. So, the interaction is so great that there is both great amount of convergence and divergence, and this is also seen at the level of brain, which we will discuss in future classes. In future classes, while we are discussing primary motor cortex, while we are discussing cerebellum, while we are discussing basal ganglia, I will be coming back to this theme of convergence and divergence, but we will try to see where there is convergence and where there is divergence. At least it is sufficient to see that inputs from multiple sources, when they come to a particular place, that is called convergence, and a command from one source, if it goes to multiple places, that is called divergence. Okay. Both are present in this system. Okay. We discussed the case of the flexor reflex afferents and the flexor reflex. If there is imminent danger that is posed to, say for example, my right leg, so flexor reflex afferent detects the presence of, say, a nail or a thorn or something like that, right. then there is going to be flexion of my right leg, withdrawal from the ground, right. When that happens, I have to balance my body, otherwise I will fall down. I have to balance, I have to ensure that I do not fall down. For that to happen, I have to activate the extensors of the left leg. Now that means there is an interlimb coordination in this case, and usually this is, say for example, from if this limb is withdrawn, the other limb will extend. If the left limb is flexed, then the right limb will extend. So there is this there is this reciprocal innervation in that, in some sense. So this phenomenon where a flexor is withdrawn is called as a flexor reflex, which we have seen in the earlier, and extension, a relatively concomitant simultaneous extension of the other muscle, of the other limb, is called as a crossed extension reflex. These two happen approximately simultaneously, say at around the same time, so that the person does not fall down and damage or cause injury to his body. So that is important. And these also involve several spinal interneurons. Now again, one more thing to see is that there is also between joint coordination that is achieved, which is also similar to the mechanism that is described here. So there is reflexes that control other joints, there are reflexes that control the contralateral limb, the limb on the other side of the body, etc. These are not monosynaptic. So when I say reflex, you should not imagine that this is a monosynaptic reflex. These are polysynaptic reflexes. Delays are greater than 50 milliseconds. So these are polysynaptic reflexes. The response time is going to be that much. You should at least survive for that much time before the response comes. Otherwise, if you fall down within that time, then you have fallen down. So basically, so the stimulus was strong enough to make you fall down. Okay, so that is the case of interjoint and interlimb or crossed extensor reflex. Okay, so far what we have seen in this class is the case of tonic stretch reflex and how tonic stretch reflex can, or the threshold of the tonic stretch reflex can be used as a control parameter. We will discuss this in greater detail in future classes. And tonic vibration reflex and how vibration causes a difference in the H reflex amplitude, and interaction among reflex pathways, and there is the case of interjoint and interlimb reflexes. Again, both are of polysynaptic origin, and the case of flexor reflex and crossed extensor reflex. You have seen these things. So coming up next is the topic of pre-programmed reactions. So what are these? These are considered to be some sort of reflexes, or the middle ground between reflexes and voluntary actions. These are triggered reactions whose amplitude and characteristic are already programmed, and just the stimulus, presence or absence of the stimulus is sufficient to start the execution of this reaction. Okay. So this we will see in the next class. Okay. Thank you very much.